Welcome back. So in this video, we're going to look at what are mutually exclusive events. This is also known as the OR rule. So mutually exclusive events are where events cannot happen at the same time. And the other thing to be aware of is when you add the probabilities up of mutually exclusive events, it will always come to one. So this statement here, if events A and B are mutually exclusive, we can say the chance of getting A or B is equal to the chance of getting A plus the chance of getting B. Let's look at this through an example. So if I throw a coin, what is the probability of getting a head or a tail? We know that one because the chance of getting a head is equal to a half, and the chance of getting a tail is also equal to a half. If we add those together, a half plus a half is equal to 1. What about the second question? What is the probability of getting a head and a tail? You can't do that. You can only get a head or a tail. So events are mutually exclusive if they adhere to that. So I've left the two explanations. The sum of probabilities of mutually exclusive events is 1. Mutually exclusive means where events cannot happen at the same time. So let's look at a couple of questions. Which of these events are mutually exclusive? The first one, winning or losing in a rugby match. Well, there's that magic word. So you can win or you can lose in a rugby match. You can't win and lose. So they are mutually exclusive. Sun shines or it rains. That's a bit trickier because you could have the sun shining or it could be cloudy and rains. But also think about this. We've all seen rain when the sun is out. So they can happen at the same time. So therefore they are not mutually exclusive. Let's look at C. What's the probability of getting a 3 or a 5 on a die? You can get a 3 and you can get a 5. You cannot get a 3 and a 5 together. So those events are mutually exclusive. Again, that magic word, the or in there. What's the chance of selecting a book that is a mystery or a romance book? Now that word or's in there, that throws us off a little bit, so be careful. You could have a total mystery book with no romance in it, or you could have a romantic book with no mystery in it. But you can also have a romantic book with mystery in it, or a mystery book with romance in it. So it can be mystery and romance. So therefore, it doesn't adhere to our or part of this. So no, those events are not mutually exclusive. Okay, let's take this one step further. So in this question, we've got a table showing the probability of a student choosing drinks each day. So we can see choosing tea, coffee, hot chocolate, we don't know, and a cold drink. So I've called that X for the time being. Now, what we need to understand is this is one drink at a time. So if I add these together, the probability will be out of 1. So I could work out the value of X. So if we had zero point 0.2, zero point 0.4, and zero point 0.1 together, we get 4, 5, 6, 7. So 1 minus 0.7 is 0.3. So we can see that the chance of getting a hot chocolate is 0.3. So there are two ways of dealing with this question here. What is the probability of a student choosing a hot drink? So we could add all the hot drink probabilities together. And if we do that, we'll get 0.9. Or what we could do, because we know all of the probabilities are out of 1, we could say it's 1 minus the chance of not getting a hot drink, which is 0.1, because that's the chance of getting a cold drink. And that still gives you 0.9. So two ways of dealing with that question. Okay, let's look at the second question. Going to move that up. Right, so the student drinks 8 cups a day. How many times would you expect the student to choose tea? So we're dealing with this over one day by the looks of it. So we know in this case, the probability of choosing tea is equal to zero point 0.2. So we would expect tea to occur 0.2 multiplied by 8 times, and that gives us 1.6 cups. So we're going to say between 1 and 2 cups per day. Now we could extend this question. What if this question was, how many cups of tea would that student expected to drink in January? So what we would do here, well, we know the probability of drinking tea is 0.2. We know that the number of cups per day is 8. And we just need to know the number of days in January. Well, there are 31 days in January. So if we multiply those together, we get 49.6 cups. So therefore, we're going to say around about 50 cups of tea should be drunk by that student over the month of January. So to recap, what are mutually exclusive events? Very simply, they are events that cannot happen at the same time. As always, if you've got something from that, please like and subscribe. And the next video is about independent events, also known as the AND rule. So it complements what you've just done.